G'day and welcome back. Today I have this radio here. It's made in Switzerland around about the end of the 40s, 48, 49, somewhere around there. The brand name is Paillard. This is an export model. The model number is 3601B. This was given to me by my friend Craig in Melbourne when I was down there a couple of years ago. I was helping my mother-in-law clear her house out for sale, and I did a little video on it and just tested it out. I don't think I got it working. I'm reduced now to working on cardboard packing boxes. I'll power it up through the dim bulb and see if it will do anything. The dim bulb's powered. I'll turn it on. No, there's nothing there. In fact, there's not even any crackling. There is some hum in there, but yeah, okay. Well, let's not break it. I'll turn it off. Okay, that's as far as I got. I put some power on it and that was it. Pretty standard setup, I think. It's a volume, I assume. Yeah, volume there. This one on the outside is the wave change switch, and the one on the inside is the tuning. Around the side is the tone knob. It's missing the knob. I might have to try and make one. The dial is in really good condition, and it's got a load of shortwave. 1, 2, 3, 4, 5 different shortwave bands, and there's the broadcast band down the bottom. This is the original cloth on the front. It's very grubby. I don't know that I'll be able to wash that out. We'll have a go, but I may have to change that. The cabinet's pretty ordinary. It's got water stains on the top. There's almost no finish on the top of that. The bottom corner here is separated. I'm not sure if it's the bottom corner here is bent down or what's happened. Let me spin it around. I'll see what's at the back. Here's the back, and look, it's had water running down it, I think. It's gone down there and then along the edge here. Pretty standard layout in the back. The antenna there. Here's the serial number and model number, 3601, made in Switzerland. External speaker and gram input. These pins are for the AC supply. I think there was a socket that fitted on there. To get the back off, it's just got these little latches. There's the back of it. Looks pretty standard sort of setup. It's got the little lock-tool valves in it. It's got a giant, I think, 80 tube in there. Here's the power cord. And there's a little socket that goes on the back. It was probably fitted, yeah, it's riveted. It was probably attached to the backboard originally. Looking at the transformer, it has a little pin there to change the voltages. And it's got little tangs here. I reckon it might have had fuses in there at one point. They're not there now. It has an 8-inch speaker, but it's a roller speaker, so that would be a replacement. And I'm not sure what that is, but that's also a replacement. It's got tape where it's been joined to the original wires. It's only got 2 wires, so it's some sort of choke. And what's that thing? Oh, it might be a connector perhaps. Does it pull off? Don't know. Alright, I'll leave it for a minute. I'll take it out of the case. There'll just be the 4 bolts underneath, the knobs, and then I'll take it out. The chassis is out, as you can see. I had to take the speaker out with the chassis. It overhung this back plate here, and you couldn't get it past, so that had to come out. I removed the 80 rectifier so I could get to the nuts. This thing here is a socket, and it was just pushed onto the back. It was hard to get off, but that's all it is, just pushed on. There are fuses that go in these little contacts here. They're 80 milliamp. They're the torpedo type with the pointy ends. You can't get those anymore, not at that low amperage anyway. This is the roller speaker that's been replaced. The original speaker would have been a field coil, so they've replaced it with a permanent magnet, and they've used a choke to substitute for the field coil. It would have been nice to have the original, of course. I will set it up to put some power on. There's a few things I need to do. First, one of the things I will do is clean the pins and sockets on these lock-tool valves. They always give trouble. A radio I did late last year had lock-tool valves, and I was using a screwdriver to pry them out, and someone in the comments said, no, you just rock them out. I'd completely forgotten about that. I knew that. So you apparently just push on that and pull it, and it'll come out. Okay. Well, it does. Looking at the pins and the socket in there, it doesn't look too bad. I have a schematic. It's not for this model. It's not for the export model, so it's just the local model. Over here is probably a bit different. The rest of it's probably pretty close to what I have here. Here's the transformer rectifier. There's the 80 valve. There's the power supply coming in, and there's a little capacitor going to ground there. I'll snip that off before I put power on. There's the different voltages. The secondary here goes up to that fuse. There's another one here, of course. They're the 2 80 milliamp fuses. It's good they give you the resistance values of the different windings there, so that's good. 3 ohm, 4.5, 17. If I add those up, that's 28, 34, 37.5. So that should be 37.5 ohms on the primary. I've switched on the switch at the front there. We should have, what did I say, 37? 43. Yeah, okay. See if it's going to ground. It's doing something there. Oh, it's charging that capacitor going to ground, that's why. These two terminals here are the full extent of the secondary, and we should go to ground here. And if I mark to there, we should get something. 391 and it's 373 there. So the secondary looks like it's intact. I'll put some power on. We should be able to check the secondaries at those 2 points. There's the capacitor going to ground. I'll see if I can snip it out. That's got it. I'll just move it out of the way. Here's underneath the chassis. It all looks good. It's plastic wire. There's a new capacitor there. Yeah, it looks alright. I don't think there's any dangerous issues there. There's a number of capacitors with shielding on it, and it might be a bit hard to see, but they've got a copper tube or something over them. So they've just slipped them into a bit of copper, soldered straight on the side of the copper there for an earth. I've connected all the power up. The switch is turned on. I'll put this on. We're on dim bulb. And we're going to power the filaments. So, yeah, we got a fair bit there. 15 watts, 14 watts. I've got the meter on AC. If I put that on there, 345. I'll try and get out of there. And 341 or 345. There we go. So the transformer's working. Before I go any further, I'll clean the pins and the sockets for these little lock door valves here. I'll connect the speaker up and see if the radio works. I've cleaned all the valve sockets and pins. I've put wire across where those two fuses were just to short them out for the time being. I've got the speaker on and I've got an antenna in. I'll turn it on here. Let's see what happens. Dim bulb, of course. Let's see what it does. Ooh, it's fairly bright, but it's dulling off. 35 watts. Doesn't seem too bad. And it's dulling off considerably now. Voltage is coming up. 34 watts. I don't know anyway. Yeah, so that's doing alright. Can't hear anything. Oh, hang on, I can. Oh, it's crackling. I think it's working. I don't know which way this wave switch goes. I'll go down here. Go back the other way. There it is. Woo.
Podcast and broadcast.
Video.
This is Conversations with Sarah Konoski.
It works.
You can find more conversations on the ABC Listen app or go to ABC.
The voltage is coming up. It's reforming those filter capacitors, I assume. 34 watts. Gee, that's pretty good.
Hibiscus. This conversation was produced by Maggie Morris and recorded.
Catch you the next hour.
That volume pot's really noisy.
Get ahead of the news.
How about that?
Good afternoon. With ABC News, the community of Clermont in Central.
Yeah.
Those killed in the Bondi Beach terror attack.
Well, there you go. I've turned it off here. It works, and it's not surprising. Most of these radios do something. I'm not sure why the fuses were missing. Maybe somebody's decided to take it out so people wouldn't plug it in. First thing I'm going to do is take this dial glass out. I'll remove the valves, and I'll take it out in the workshop, and I'll give it a good clean down. The chassis looks and feels like it's CAD plated, so it's not going to clean up very well. This is a bit of IPA, isopropyl alcohol. Yeah, it's exactly what I thought it would do. It's dirty and it's not going to clean up. I'll try it with a toothbrush. Not going to get any better, I don't think. No. So this isn't going to clean up very well. I'm not too concerned. It's got a back on the cabinet, so yeah. Alright, well, unfortunately I'll just get the dust off and that'll have to do. I have the chassis back inside and it's cleaned up better than I thought it was going to. I used a scourer to clean it off with the isopropyl alcohol, and yeah, it's come up okay. Maybe I could put some wax on it, just make it look nice. Maybe a bit of that polytrol would be good. Anyway, we'll worry about that later. I brought the radio back inside and I was going to start changing components, and I thought, no, I'll put the valves in, just make sure it's still working, and then I can start changing components. It started off alright, there was a bit of crackling and noise, and then I noticed some arcing in this valve, and I thought, no, it can't be in the valve. It was actually coming from the corner of this IF can. I've removed the nuts underneath and I was going to lift this can off, but I can't. Somehow it's retained on the coil. So I'm going to have to flip it over, unsolder it and remove the whole can. We'll see what's going on. There's the bottom of it there. There's the two nuts that I've removed from there. Yeah, it's not a lot to take off. So I'll just unsolder them. Should be easy enough. I have it out and there's a screw holding that insides in the can. I could have undone that and just left it connected. Anyway, live and learn. Look at that. Alright, now what's going on? Here's the little carbon track here. I'm assuming that was tracking to the can, which has gone to ground, of course. Now it's got a little leg sticking out here. Maybe it started tracking across. Yeah, made a bit of dirt in there maybe, and then it started tracking across. So that's been doing that for a little while, I would say. I'll have to dig that out. I'll bend that away a little bit. I'll give it some clearance, and maybe that will cure it. I'm trying to dig this out, and it's got a very deep trench there where it's been tracking across. So this has been doing this for a while, and perhaps me cleaning it and just reactivating the carbon a bit with the solvents has enough to start it off again. I'll bend this little tab away so it doesn't tend to track in the same place anymore. It's actually underneath that as well. Alright, I'll continue to clean it out. I've cleaned the carbon out thoroughly, so I don't think there's any carbon left. I snapped off that little bit of metal sticking out there. I don't think we need that now. I was going to put a bit of epoxy in there just to seal it up, just to be 100% sure. That'll take a little while to go off. I'll reassemble the whole thing and I'll see if the radio still works. I've got that IF transformer refitted and I was just soldering it up. This capacitor here needs to be replaced at some point, so I might as well do it now. And that's this one here. I might as well change this one at the same time, and to get to them I need to remove this one, so I might as well change this one as well. I've replaced the two capacitors. I've replaced this capacitor. I did think of restuffing it, and then I thought that's silly, you can't see it, and none of the others are restuffed, so I just put a new one in there. I'll turn it over and hopefully it'll work. I have the valves in, the speaker's connected. Let's put some power on. It's also got an antenna. That looks much better. That came on pretty bright the first time. Either that or something's not working. Actually, that looks like something's not going because we've got way too much power. No, it's coming up. Yeah, it's what I feared. It's not going to work. There's nothing. That's hot. That's hot. That's cold. You can't see the filaments in these. You can't feel any heat in there. Okay. I have the radio upside down. I'll do some voltage checks. As I said, it doesn't seem to be pulling quite as much current as it used to. I did change the capacitor, of course. This is the first capacitor in the pi filter. We should have 300 odd volts there, 218, alright. Then it goes through the field coil, comes back here. We should have similar there, 216. This is the output valve, but I can measure the plate voltage here, 198, and this is the screen, 215 or something. This is the coupling capacitor for the output valve. Yeah, so it's there as well. So that resistor's okay. And we've got voltage the other side of it, and that's coming through as well. This valve here is the 7B6, that's a double diode triode, that's the grid there. Well, that's coming through. This wire here is the signal to the volume control. Okay, so the volume control is working. There should be full voltage there. 216, and it should come out here, and that's clicking as well. So the signal's still getting through. That comes out here. That's the plate of the IF amp. I think that's the screen. 66. I don't know what it's supposed to be. Now 1, 2, 3, 4, 5, 6. Doesn't seem very loud, does it? This one here should have voltage that'll go over there to the plate of the mixer. So the mixer's got voltage on it. I think that one there's for the oscillator. Should have something on it, yeah. So all the valves have got voltage on it, but there's nothing coming through. It seems to stop here. That should be louder than that. I wonder if that valve's playing up. I've done a little bit more investigating off camera just to try and speed up the process a little bit. I tested that 7H7 valve and it tested perfectly, so that's okay. I connected my signal generator to that 7H7 valve and I put the IF frequency through it, and I tried to adjust the IF can that I'd worked on, and the bottom part of it was working, which is the primary side, but the secondary side had no effect. So I thought, oh, maybe the capacitor's not working. So I took the can off again, just pulled the leg away from the capacitor and tested it, and it was perfect. It's exactly on spec. So I put that all back together again. I have the signal generator on 470, which is the IF frequency. It's going straight in the antenna, so I can hear it with my old school sniffer here, but it doesn't come out here. It should come out here, and it doesn't seem to at all. So that's the primary. So I thought, oh, this capacitor here, maybe that's dragging it down. So I changed that, which means I ended up changing this capacitor and a few others along the way. I then thought I want to run it on full power, so I changed this capacitor here, the filter capacitor. That meant changing some resistors and another capacitor under here. So I've done a good deal of the capacitors. The problem is, it's there, it should come out here. It's just not there. I'll check the voltages. This should be the B+, 176. I'm still on dim bulb here, 176. So that's going through that transformer there. That's going to the grid of the 7H7, and we've got 0.66. That should be negative. That should be negative. That's the grid of the 7H7, and we have got, it's only 0.3. It should be a minus though. This is the bottom of the mixer valve, the 7S7. 1, 2, 3, 4, 5, 6. It should be that one. What have I got there? Well, that's got a minus 1 volt. That should be a minus there. Let's have a look at the schematic. That's the 7H7 valve, which I just put the meter on that grid there, and that's going through that secondary there, and that'll be the AGC line. There's your big resistor there. So I follow it up here. So there's the two diodes. So that should be negative. Goes through there, filter, or capacitor, filter, and up there. So that's negative there, but it's positive there. What's going on in here? I'll take the cover off that IF transformer there. Have a look at that. It's got the same tracking as the other transformer. That's the B+ terminal there, and it's tracking to where the stud was. Oh, I wonder if it's actually tracking over to that secondary there. That's the secondary that's got a voltage that it shouldn't have. Let's see how conductive this carbon is. 7 meg. Depends where I put it. We're getting down to under a meg, 800K. To clean that up, I'll have to remove this IF can, so I'll do that and I'll come back. I've removed the IF transformer and it's under my digital microscope. This terminal here is B+, that one's the secondary, and this is where the stud was that it's been shorting out to. You can see the carbon track going from the primary there, the B+, over to the secondary, and then underneath it and around the side. Like last time, I'll clean all that carbon out and I'll put it back in the radio. I'm having a lot of fun with these IF transformers. I cleaned up all that carbon that was in here. I put this back together, put it in the radio. The resistor that supplies the B+ to this IF transformer started to get hot. So I disconnected all the other wires except the B+ supply, and the resistor still got hot. So I measured from here to here, and it had about 800k resistance between these two terminals here. So what I've done to these two is remove these terminals. It's retained with a little bit of a crimp down the bottom there. I just straightened that out, took these out, cleaned all this up, cleaned up the terminals. I've put them back in. I had to put a little bit of epoxy there to hold them, and now we've got no continuity. I'll turn this around to the other side. These two terminals here are isolated. They've still got the capacitor on it and the wire, but the other end's disconnected. And if I put my meter on there, we've got, what, 30 something meg. There's no evidence of any carbon there. I don't know what's going on. So I'll do the same, take all this off, push these out, clean it all up, and I'll put it all back together, and hopefully it's okay. I'm going to have to take the other transformer out and check that as well. Out of curiosity, I had a look at this 7H7 valve and the normal operating specs, and it says it can actually go positive 1 volt to negative 2.5 volts. It's dependent on the plate voltage. We had about 170 volts on the plate. If I remember, I'll check that voltage again once the radio's working properly. I've cleared all the shorts on this IF transformer and I've refitted it. This is the resistor that was getting hot, and it actually started to smoke a bit. It feeds B+ to the primary at this terminal here. The B+ goes through the primary, comes out here, and it goes over here to the plate of the 7S7 mixer. I have my multimeter on DC volts, and I've connected it across this resistor that was getting hot. It's supplying that B+, as I said. So any shorts in there now, it should show a current flow. I've put power on. There's no mixer valve there. I've taken that out. And the meter says we're not dropping any voltage. So the short's gone from in there. I've turned the lights off so we can see what's going on. I'm going to connect this wire up to the output of that primary. Just keep your eye on this socket area here. There it is. So there's a short in there as well. I've never experienced carbon tracking like this before, but I remembered Shango had the same problem with an Electro-Home radio he did a couple of months ago.
Man, that is carbon tracking if I have ever seen carbon tracking.
So there you go, it does happen. I didn't need to pull those two terminals out like I said I did. What I did was get some acetone and I thoroughly rinsed it out and cleaned everything off with a brush, and it removed the shorts. So I think I'll have to take this out to my workshop and do exactly the same to this. Just flood it with acetone and brush it and just try and get rid of whatever material's on there. I took the chassis out to my workshop. I soaked it in acetone. I brushed it. I blew compressed air through, trying to clean it out. It made no difference at all, as you may have guessed. I deriveted it from the chassis in an attempt to try and separate the two pieces of phenolic and get some spray in there and perhaps clean it out. Yeah, it just didn't work. It has more shorts in it than my wardrobe cupboard. To demonstrate, on the back there, you can just see the remains of the rivet, and if I touch it on that wire there, you know, you get some reading, 25 meg or something. Yeah. So whatever's got in there, I've got no idea. It's tracking from that terminal all the way to the ground rivet. I don't have any spare lock tool bases. I went online. I found a guy only 20 minutes away from here on eBay. He's got them there. It cost me $16, free delivery. I've ordered 4 of them. They'll come within a week or so, but I'll probably end up changing all 4. In the meantime, I still have some capacitors to replace. I'll pull out that original IF transformer and just make sure that's all clear. When I had it out the first time, I didn't really check it for shorts. I wasn't looking for that sort of thing at the time, so I'll pull that out and I'll make sure that's okay. As I said earlier in the video, these paper capacitors are wrapped in copper. It's probably brass actually, but anyway, they're wrapped in brass and then earthed. So they're all like that. They've all got shields on them. Just as an example, I'll do the other ones off camera, but I'll pull this one out. I'll have a look. It's attached at that end to that socket, and it's attached at the other end to the tone control. So a couple of solder points and that'll come out. there it is, and it's just a bit of, it's probably brass, and it's just been soldered along a join there. They must put the wax in afterwards. They must put the capacitor in there, fill it with wax. I don't know how they've done it. It has C54 written on it. This was on the tone control. There's the volume. It'll be up here somewhere. There it is. Tone control. That'll be it there. 0.025 microfarad. There is no C number there, so C54 is not there. I'll test it just for fun. Let's see what we got. It should be 0.25. It's coming out at 0.34. So yeah, it's probably no good. It does have B plus on one side of it, so a bit of stress on that one. I'm going to replace it with this one. This is a 0.022. We don't have 0.025 anymore. I'll make sure the outer foil's going to ground, and that'll do. I don't really think I need to shield that capacitor. That last thought was only brief. I ended up rolling out a little brass cover here, and it's very thin brass, and I've found the shield, the outer shield, and that's that end there. I've marked it with green texture, as I always do. So I'll solder a little braid on there, put some heat shrink over it, and that'll do. I've changed my mind again. I've clamped the capacitor in the vise there. I'm going to try and solder a bit of this earth strap on here, and hopefully it won't melt the capacitor. If I put that on there, the jaws of the vise should draw the heat away, I'm hoping. There it is. It's not the neatest job in the world. I could have used a much thinner solder wick and wouldn't have been so lumpy, but anyway, that'll do. There's the capacitor there. I've grounded it onto that stud there. I've wired this end of it back to the tone control. Needs to have a wire from there to there. I'll put something to remind me where that goes. The videos run for about 30 minutes, and I'll try and keep them to about 30 minutes. I'll change these capacitors off camera while I wait for the new parts to arrive. I think this is about the first time I've not got a radio to work. But anyway, I hope you enjoyed what we got up to today, and I hope you can join me next time for my next radio adventure.